Week 6, lesson 8. Okay, so for the first example, which is actually sort of these 6 problems up here at the top, I would like you to kind of treat this as a warm-up, right? Actually, as soon as I give you the directions, I want you to pause the video and see if you can actually do this without me doing it for you. So I'd like you to write the first 5 terms of each sequence. Okay, this is telling you that you're plugging in integers that are positive. So you're going to be plugging in 1 and 2 and 3 and 4 and 5. Okay, and you should get these answers. So now that you see all the answers and you're checking yours, what's going to happen is you are going to be given the problems like in this format. Like you're going to be given these, and you're going to have to come up with these rules over here. You're going to have to come up with these things. So there's some definite things that I can try to help you with, but some of it just takes a lot of practice and a willingness to not give up. Okay, so I'm going to fill in all the examples down below, and I'm going to show you how to do them. Okay, so if you're looking at the top one, which says arithmetic, the way you can tell, and you've done these ones already, so I'm hoping this is kind of fairly on the easy side, there's a common difference, right? You are adding 5, and here you're adding 5, and you are adding 5. So the notation here is, I need to know what you're adding, so that's going to be the 5, and then this number that goes after is literally sort of the missing term that doesn't exist over here, but if it did, what would it be? And in this case, that would be -8. All right, so, and you can always test it out. When you plug in 1, you should get -3. When you plug in 2, you should get 2. When you plug in 3, you should get 7, etc. And the condition here is that R is an element of the positive integers. Okay, next, the geometric one. And again, you've done these before also. The pattern here is multiplicative. You're multiplying by 2, and you're multiplying by 2, and you're multiplying by 2. So the rule, at least how you start it, is you have whatever you're multiplying by raised to the r minus 1, and then you also need here whatever the first term is. All right, and again, here the condition is that r has to be an element of the positive integers. Okay, now the quadratic one is really interesting, at least to me, but I'm a math nerd. So here, if I'm adding, right, I'm adding 3, and here I'm adding 5, and here I'm adding 7, here I'm adding 9. Okay, that doesn't, it tells you it's not arithmetic. It's also not geometric, but look at what happens when you add, or when you find the second differences. This is adding 2, and that's adding 2, and that's adding 2. When that happens, it's quadratic. All right, so when it's quadratic, you're going to start with this, and then it may take some adjustments. There may be a number out in front, there may be an addition or a subtraction over here. This particular one, if you look really close, these numbers are all 2 greater than a square, right? Think about your square number. So 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, and if you look really close, all these numbers in this list are exactly 2 more than that. Okay, and again, in this situation, r is going to be an element of the positive integers. Okay, and part of the reason that all 3 of, let me highlight, the reason all 3 of these are positive integers is because of these ... dots. Okay, so take a look at this next example. It doesn't have the ... dots. So there's going to be another condition, but we'll get there in a second. Okay, so this next example, the exponential one, if you're looking close, this goes up. Sorry, I keep forgetting to switch out of highlighter. Here we go. This is addition by 4, and this is addition by 8. This is addition by 16. This is addition by 32. When you see something like that, it has to be exponential. And you can see that all of these can be written as a power of 2, right? This is 2 squared and 2 cubed and 2 to the 4th and 2 to the 5th. So that number is where you start as far as the base. Then you're going to raise it to the n plus 1. Sometimes that's a minus 1. Again, you may have to sort of test it out, all right? And then you can kind of see there's a very close connection. Hopefully I can highlight this, or maybe I'll circle them, right? This 3 is 1 less than 4. And this 7 is 1 less than 8. And this 15 is 1 less than the 16. So you can kind of see that the adjustment I need to make here is to, give me a sec, here we go, subtract 1. Okay, now, yes, r is an element of the positive integers, but r also is less than or equal to 5. And that's because there's a very finite number of numbers in this list. Okay, next, factorials. Now, you've played with factorials a little bit, I hope. Let me move this up a little and change colors. Okay, so this one you kind of have to recognize that 1 is just equal to 1, and 2 is equal to 1 times 2, and 6 is 1 times 2 times 3, 24 is 1 times 2 times 3 times 4, etc. Okay, so the rule is it's going to be r factorial. And in this one, r is an element of the positive integers, again, because of these dot, dot, dots. Okay, next, alternating signs. You're going to have 2 almost separate rules when you see alternating signs. Okay, so let me show you how to take care of alternating signs first. And that should be blue, right? If I want to keep my colors consistent. Here we go. Okay, so if I want alternating signs, I can do this. I can put -1 to the r plus 1. Okay, and try that out. Try plugging in 1 and you will get a positive number. Try plugging in 2, you'll get a negative. Plug in 3, you'll get a positive. Plug in 4, you'll get a negative, right? That's what's going to make the signs alternate. Once you've got the signs alternating, you can ignore the negatives and literally just look at the 1, the 2, the 4, the 8, which is exponential. All right, so you're going to multiply this by your exponential rule, which is this. Okay, r is going to be an element of the positive integers. There are only 4 of them, so r has to be less than or equal to 4. Okay, now this one is one of my favorite ones. The whole series here, the whole sequence here is just 2, 4, 2, 4, 2, 4, 2. Okay, so I'm going to start actually over here, and it should be in red if I'm going to keep my colors consistent. R is an element of the positive integers, and r is less than or equal to 1, 2, 3, 4, 5, 6, 7. Okay, so check this out. Sometimes if we were in class, I would approach this different. But what I want you to see is that these numbers are all related to 3, right? This is 3 minus 1, this is 3 plus 1, this is 3 minus 1, this one's 3 plus 1. So what I need is a 3, and then I have to add to it either 1 or -1. That's the same thing as alternating signs. Okay, so now that I've got that chart, let's see if we can go to the next page and fill some of these other things in. Okay, so you've seen sigma notation. This is not your first rodeo. So if you're asked to find the first 5 terms, you just have to plug in 1, 2, 3, 4, and 5. Okay, so I'd like you to pause the video, see if you can fill those in, and then the answers will appear. Ta-da! Now, question. Did you forget the plus signs? Because if you forgot the plus signs, it is wrong. This is considered a summation notation, which means that you should be writing a sum. Okay? And even though it only said to write the first 5 terms, all of these have much more than that, right? This one has 10. This has an infinite number. So you need to have these dot, dot, dots at the end. And if you don't, that would also be considered to be wrong. All right? And then moving up, your last thing is, let's write these in sigma. It's also called summation notation. Okay, so let me start here. I'm going to go ahead and start this at 1. In fact, I'm going to do all of them at 1. All right, Some of these go on forever, like this one, so I can go ahead and put an infinity. And the other ones have a finite number of terms. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, that should be the easy part. Okay, the harder part is figuring out what goes after the summation. What are we plugging into? So this first one is arithmetic. It has a difference of 8. No matter where you are in this list, you are adding 8. So I know I have this 8r, and then the missing term that would be out in front is a -5. All right, this is very, very clearly just alternating signs. You've seen this before. You could have this as one of your options. It also works if you had -1 to the r minus 1. All right, again, and it may take some practice, just some playing around with it. All right, and then this last one, the first thing I see is alternating signs. So let me get this in there. And then now that I can ignore the alternating signs and only focus my attention on the 6, the 12, the 24, the 48, etc., I can kind of see that I am multiplying by 2, right? So it's a geometric sequence. So the 2 is what's being raised to the r minus 1, and the first term is going to be that 6.